The majestic Atlantic salmon, Salmo salar, was once common in New England. The Atlantic salmon is an anadromous fish, meaning it lives its adult life in the ocean but is born and spawns in freshwater rivers. The Connecticut River was once teeming with these silvery salmonoids. It's estimated that before European colonization, upwards of 50,000 fish made their way up the river annually. It is not unsurprising that the loss of 50,000 10-pound fish annually to a river system had impacts on the ecosystem. Young Atlantic salmon and salmon eggs are an important food source for a wide variety of other species. Not all fish survive the journey upstream, so their carcasses provide nutrients for the river community. Juvenile salmon live in the rivers where they are born and feed on phytoplankton and insect larvae. Atlantic salmon spend their adult lives in the North Atlantic Ocean and consume small fish and crustaceans and are preyed upon by larger fish such as striped bass, cod, and haddock, as well as birds, seals, and whales. The loss of an entire population also has large effects on the genetic diversity of the species as a whole.
By the 19th century, dams, industrial pollution, and overfishing had driven the species from the Connecticut River. Over 2,500 dams constructed throughout the Connecticut River system impeded the ability of the salmon to run, move up and down the river system, and altering the substrate composition of the river by impacting the spawning sites. Today, most of these dams are outdated and serve little or no use to society. With the Industrial Revolution happening all along the Connecticut River, it became exposed to pollutants from factories like the paper mills. Also, in the 19th century, the growing farming movement led to an excess of phosphorus and nitrogen entering the river. This change in chemical composition in the river posed trouble for a relatively sensitive species like the Atlantic salmon.
There are large social and natural impacts to the reduced salmon population in the Connecticut River. The eggs of Atlantic salmon are food for other species of fish, such as trout, other salmon, and suckers. The loss of Atlantic salmon deprives these other species of one of their sources of food, creating a ripple effect along the entire food chain. With reduced population, the genetic diversity of Atlantic salmon also suffers. Genetic diversity is important among any species as it is vital for the survival and adaptability for a species. From a social standpoint, the population reduction of Atlantic salmon has also had negative effects. Fishing is a large part of the culture of many people who live along the Connecticut River.
Fishing is a large part of the culture of many people who live along the Connecticut River. With lower salmon populations, recreational fishermen and women must seek out alternate places to fish for Atlantic salmon. In the 1960s, the Fish and Wildlife Departments of Vermont, Massachusetts, New Hampshire, and Connecticut joined together to try and restore the Atlantic salmon population to the Connecticut River. They worked to remove some of the pollutants from the river that remained from the industrial era and started forming passageways around the 2,500 dams that block the salmon migration up the river. A couple thousand hatchery-raised Atlantic salmon were stocked throughout the river, but after about a decade, the attempt was determined to be unsuccessful, as nearly all of the stocked fish had died or went to sea and never returned. However, the salmon that were stocked were a different strain of Atlantic salmon than those that originally inhabited the Connecticut River. Later, another stocking was done with the Penobscot strain salmon, which represented a closer match genetically and physically to the original Connecticut River strain. This proved to be more successful as, over the next decade, up to 500 salmon returned up the river to spawn. But shortly after this success, salmon populations began to die off due to a decrease in the bait fish populations. The lower amount of available nutrition, combined with the rising ocean temperatures and new ocean current cycles due to climate change, caused the populations to once again drop. Then, in 2011, Hurricane Irene destroyed the fish hatchery that produced the program's salmon fry, and the U.S. Fish and Wildlife Program pulled out of the restoration program, effectively ending it.
In order to restore Atlantic salmon to the Connecticut River watershed, there are a number of factors that must be addressed to make the river once again suitable for this native species. When the original restoration program was founded, one of the important components of it was creating passage for salmon around the existing dams, which usually involve building fish ladders or passageways around the dams. However, recent studies have found that the fish ladders don't provide ideal passage for fish migrating up a river. A 2013 study by Yale University on dams in 3 major New England rivers, one being the Connecticut, determined that because of the unnatural passage chambers, fluctuations in water levels from the rest of the river. So in order to restore Atlantic salmon to the river, these older, dysfunctional fish ladders need to be replaced with a better alternative, like the more natural fish ladders that are being used in Europe and many other countries with a higher success rate. However, even building the best fish ladders does not come close to the benefits of removing a dam. So the outdated and unused dams on the river would ideally be torn down. Improvements to downstream access would also help the migration routes.
To establish a population of salmon in the Connecticut River, stocking is necessary. The Penobscot River strain of salmon has proven to be the most effective strain for surviving the Connecticut due to its genetic and physical characteristics. Salmon can be stocked as either fry or smolts, with the fry stage occurring shortly after hatching from eggs and the smolt stage occurring when the salmon are slightly larger and able to venture into salt water. Studies suggest that fry have a higher smolt to adult survival rate than stock smolt, so stocking large quantities of fry would be the most effective way to build a population in the river.
Once adult salmon begin to return to the river, they should be captured and bred to produce offspring that will develop a genetic command to migrate up and down the Connecticut River. This was done for a couple years in the 1990s, but only on a very small scale. By inbreeding these salmon and stocking their fry, a new genetic strain of Atlantic salmon could be formed, nearly identical to the native strain that inhabited the river for thousands of years. There it is.